Yay, here's the achievement pop-up. 100% on the dancing machine on the first try in the Pikuniku game with an OpenCV+Python script. Perfect. I did not write the script from scratch. I actually had an entire Jupyter notebook exploring things before this happened. So in this last part of the video, I'm going to tell you what were the steps for me to make it work. First of all, I'm used to working in the Linux environment, and it was a bit of a challenge for me to have Git for Windows and then also configure the appropriate profile for Windows 10 terminal, which I can recommend. It's a good terminal. Then I had to install OpenCV for Windows. That's a binary release. And you also have to set environmental variables, and there's a link for that as well. I also had to install Python for Windows. And then I had to install a bunch of Python libraries, the OpenCV Python, MSS, keyboard. Optionally, matplotlib, I did use that one for plotting the scores. Next, I had to figure out the code to move the Pikuniku window to the top left coordinate so that it's reproducible. And you see, you can do this with AHK, auto hotkey, but this is lame. Well, yes, because it's not from the code. Then I found some more libraries, PyWinAuto. Unfortunately, that's, as I say here, that was surprisingly difficult for me. So I ended up using PyWin32, which was much more straightforward for my use case. And you could also go the direct Windows API invocation through the C types without extra dependencies, possibly even a better way with fewer dependencies. All right, next I had to evaluate the methods. I did try the square diff method first, which kind of worked, but it could barely separate the differences of the left, right, up, down arrows. Let me see, I do have an image here. So that's an image of the SQDiff scores on a captured set of frames. And I believe the green line, it's one of the directions, so there are 4 colors on this plot. So the green one was correct, and then the blue one was correct here. But you can see that the difference between the green line and, let's say, the blue and the red is not that big. And this is also one of the methods, as I mentioned before, where you are looking for the minimum value instead of the maximum value, which is why the scores are so low here. And actually, this is just a short fragment of the frames, and see here it worked, but on the full captured video of the game, this method just didn't work. It gave me wrong actions for left, right, up, and down. Now, for comparison, let me have a look at some of these other method score plots. So here, the dashed line is at 0.95. This is plotted using matplotlib on a set of frames. And you see that here the frame separation, so the correct frame, the green one, and the others, these are much, much better. And also the detection itself is so good and flat and nice at the top. I actually did this for the full captured video, so I kind of expected in advance that it would work, but this was not the live game run. This was on a video where I did nothing on the keyboard. I just captured the arrows as they were passing by through the target circle and doing nothing else. All right, so that was the next part, to figure out the method. As I say here, I did just capture a video, essentially not a video. I captured using the MSS library frames one by one, and I saved them into a list and dumped into a pickle. And that's the frames.pickle file here that I just used in the Python notebook to play with. When playing with the capture, that's how I figured out that I only need the status bar, where the goal circle is, and not even the full status bar, that's the blue part in the bottom part of the Pikuniku window. I also figured out that you just need the goal circle and nothing else. Then I've used some open source software to cut out left, right, up, down buttons from frames. I also tested, as you can see here, I had the full buttons, and I also have 2 versions of the button cutout. So for example, I had the down arrow with a lot of white area around it, and I also had the one that only had 10 pixels of white area on each side. I don't think it makes much of a difference, but the 10-pixel version worked well with the methods of choice, so I just stuck to that one. All right, then the next problem I had to solve was the double action or triple action for as long as the score is above. And I should put an X here, do a live run. And I also did save the current game state from under this location before I attempted the live run. Now let's have a look at the notebook to see if there was anything of interest here. You see I was capturing essentially the full gaming window in my initial attempts. While screen capturing, grab the monitor, show normal image, show grayscale image. One of the gotchas for me was that I had to add the cv2.wait key after every imshow method call. Otherwise, the window would just become unresponsive, and that's not how it's supposed to work. So please always add this one after cv2 imshow. And then I was also printing some FPS, and that was it. That wasn't doing much. Then in the next attempt, I'm defining the frames list, and then I'm capturing still a full gaming window, grabbing grayscale, but then also saving the frames in this case. Then those were saved to a file. Then I tried to figure out which range of frames I need, where things happen in the target circle. In the end, this wasn't actually needed, but yes, I did figure out the frame range on my test set, where I could actually operate, or I could expect some actions. Then what did I do next? Then I figured out that I can capture just the status bar of the full window. So I did some calculations on the offset within the video, and you see I have the offsets in my attempts. So I'm actually showing the area of interest. Then what did I do next? Grayscale, still looking at some things. Not too interesting. All right, so then I've added finally counters of actions and scores. Here I probably played with the threshold. You see for the square diff normed, I had played with thresholds a bit, and then I discarded that method and I switched to the other image detection methods. And that's actually the code that was used just before the production, I believe. It's essentially the same, but this was run on the frames, saved frames pickle, still no actions. Otherwise, it should be the same code. And this is also the first time when I printed out some statistics and also checked if left, right, up, down calls match the ones that I expected, and they did match. Then there was a bit of code to plot scores. This was used for both methods as I was exploring them. I plotted all of the frames and the scores for all 4 arrows to examine them. And finally, I had the production code still in the Jupyter notebook, and it should be exactly the same, or largely the same as the script. The only difference and the only reason I brought this out into the script is that I added the try except finally for keyboard interrupt, because I wasn't sure if the Jupyter notebook would properly transmit the Control-C to the script itself. So I decided to better put it into a separate script. And as you can see, I also played a bit with window moving with different methods, and some of this code didn't work. So there you have it. It's the Dancing Machine challenge with a little bit of rather simple or very simple OpenCV code in Python, working on the first try. That's it, the project is over, and I can move on to the next project. Have a good day, and maybe see you next time. Bye.